Alright everyone, I've seen many people on Discord a little disgruntled on GRT not giving accurate results, and I think it's because they're new to it and they're not starting out on the right foot. So I'm going to create a couple more videos just to help everyone out that may be having issues with GRT, because if you think it's way off or the program doesn't work, you're doing it wrong, you're using it wrong. And I want you to remember, this is a free unfinished reloading tool. It's not like quick load where you throw items in it and it just spits out loads for you to shoot. You have to actually tune each profile for your rifle. So if there's garbage going in and it's not tuned, you're going to get garbage out. So let's go ahead and get started, and you can see how easy it is. I'm going to use a real world example of my father's Remington 78. It's a favorite hunting rifle of his. It's okay, it shoots about 1 1/4, 1.5 MOA with standard hunting ammo, but let's see if I can shoot a little bit more accurate. So for this load that I'm working on, I rechecked the twist of his barrel. I don't know why. I checked it 20 times. It always comes out 10.5 twist. I didn't know Remington, the 700, it's a cheaper 700. The 78s I think were sold by Kmart or similar stores, 80 to 83-ish time frame. I didn't know they made 308s and 10.5 twist, but it's old, it's got lots of free bore, but it's still fairly accurate. So I'm going to see what I can do with this rifle. I have a bunch of Starline Brass, or a handful of it. It's been used in other rifles. I haven't used it in this rifle yet, but I do know the shoulder dimensions on this rifle in this chamber because I've made other rounds for it. So I trimmed the brass to 2.008 inches, and then I bumped the shoulder back 3 thousandths when I sized it. I'm using CCI 250 Magnum primers, and the bullet I'll be using is the Hornady 178 ELD-Ms because I have a couple boxes of that, which I've used in other 308s successfully. I'm loading them a little bit long at 2.87 inches. Even at that length, I'm still about 116 to 120 thousandths from the lands, so it's got a bunch of free bore. And then, which with my comparator is 2.254 base to ogive, which is more important than this number, right? And the two powders I'm going to test is Varget and N150 for this example. The first step in setting up your basic load workup in GRT is to not use GRT. You want to use published data. You want to find a safe load, because that's where most guys are running into trouble. They're just jumping straight into GRT. They're plugging numbers in, plugging powders, plugging bullets, and they can't understand why they're overpressured the first time they go out. So here's what I'm doing for this load. I'm going to use Varget, and for the load data, I checked Hodgdon website, Nosler website. I found some Sierra data from Google search, but most of this data is with the bullet loaded 2.8 inches or so with a 24-inch barrel, so it's going to be off a little bit, but it's going to get me in the ballpark. I'm using 178 ELD-Ms, so I'm looking at 175 grains to 180 grain bullets here. Hodgdon says 42 to 45 grains compressed, which results in a 2690 foot per second max. Nosler 30, a little bit lower, 39.5 to 43, around 2600 foot per second max. Sierra's load data, similar to Nosler, a little bit wider window, similar max foot per second, and then they actually had a separate load data for the 177 grain, which is 41.4 to 45.1. So that's the largest window with a 2700 foot per second max. So you can see here, it's a pretty wide window, but these are all in the same general area. So what I'm going to do, I'm going to start with 42 grains of Varget. I'm going to load it just a little bit longer, so I might have slightly higher feet per second, but 42 grains is the bottom of this Hodgdon here, and it's kind of in the middle of these two, and then it's near the bottom of this one. So I think 42 grains is going to be safe, right? This is the Sandy check. I do have other loading manuals, but I'm not going to dig them out for this example. And then I'm also using N150, which really I just pulled this data from the Vihtavuori website, and this is again free. They have a lot of reloading data free on their website. This actually had the 178 grain Hornady bullet, and it says 40.9 to 44.1 with a max feet per second of 2600-ish. I've loaded with both these before. I'm going to start with 42.5, which is pretty much right in the middle. Now, granted, I'm using a 22-inch barrel, so my velocity should be slower, but we're just going to take that into account as far as when we're gathering our data. So right now I have these, I'm going to play on 42 grains of Varget, 42.5 grains of N150. I'm not just blindly trusting whatever GRT is spitting out initially without truing anything. I'm going to go with safe published data, and this is going to be the starting point, the backbone of your load workup. Now that we have a safe starting point for these load workups, we're going to go on to step 2, and this is where you actually go into GRT, and you're going to update the case volume, if you have it, the bullet length, the bulk density of the powder, the temperature you're going to shoot at. Anything you can update now, you're going to do it. All right, so let's go ahead and jump into GRT. Here we are in GRT. Now, I already pulled in my rifle profile, but I do see that I have to update some items here. So right now I'm going to put max pressure 65,000, personal preference. I said I trimmed my brass to 2.008. Right now this 55.6 is the case volume from the Starline fired in a different rifle. So this is probably going to change, but I'm going to use it. This is what I have right now for fired brass, a Starline, so I'm going to leave it. I have the cartridge length 2.87. It's 22 inches long, and twist is 10.5. All right, so I pulled in the stock GRT database for the ELD-M 178, but I did measure 10 bullets, averaged them, and the bullet projectile length was actually 3.18. So I'm going to go ahead and update that now. I'm going to leave the rest of this unchanged. Now let's go to the powder Varget. I'm going to use the October. Okay, so here we are. And then I said I was going to start with 42 grains. It's going to be 80 degrees approximately 80 degrees because I'm in Phoenix, so change that to 80. So the 42 grains, muzzle velocity right here, 2,531. Now, one other thing that I updated before I shot is the bulk density, because I check the bulk density of all my powder as soon as I buy it. I have 5 pieces of brass, different brands of brass, just so I have a variety. 5 different pieces of brass with their primer, spent primer in it, set aside, numbered 1 through 5. I measured their case volumes with water, this item here, on those five pieces of brass, and then I just keep that stored. I keep them set aside, and then every time I get new powder, I measure the bulk density with those 5 pieces of brass. So I'm going to pull that profile up because I copied it, and here's my Varget, just plain Varget PCD for my lot of Varget with the bulk density updated. So I load that. You can see here the load ratio is 94.8. Let me go back. And before it was 92.3. So it already changed my load ratio that much. So let me pull that in again. PCD, that's my PCD. There we go, 94.8. Also, I'm not too worried about the burp propellant right now because I think it's going to get better once I tune this profile. Oh, let me go back here to 80. So now I'm going to jot down this 2531 muzzle velocity. I also want to find out what it is at 65,000 psi right here. So fastest way is just to click on this star, type in 65,000 psi, calculate propellant mass 44.2. Okay, so it plugged in 44.2, but it's not at 65,000. Or why is that? Well, it's because the load ratio is pretty much topped out. So you're gonna have to, if it does that, you have to manually update it. So let's go 45. That's pretty close. 45.33. Okay, 45.02 grains at 80 degrees is predicting, well, actually this is irrelevant. What's relevant is this pressure is going to result in this velocity, 2710. So no matter what I'm shooting at, if I'm seeing 2710 feet per second, I'm at my max pressure because the pressure equals velocity. All right. So I'm also going to jot down that number. So I have an estimated feet per second, then I have a maximum feet per second. So if I'm testing these rounds, I'm hitting this, I'm over pressure, I'm going to pull the rest of the bullets and drop down a grain or two. Now let's look at the N150 and do the same thing. This is going to be 2008. Leave that. So this was 318. I'm not using N140, I'm using N1. I'm going to use, just go ahead and plug in my PCD right here, N150 PCD. So here the load ratio is 95. If I actually use the stock profile, N150, load ratio is 100.8. So it's already compressed, right? Which isn't right for my powder, my lot of powder. So that's why I always check PCD. You're always going to be closer just starting out measuring your PCD. So there's my profile with the PCD updated. Let's make this 80 degrees and 42.5 grain. That checks. Both these loads are around 52,000 PSI. And then we're looking at 2499 muzzle velocity with this combination. And then let's look at where the max is. So 65. Calculate, apply. Ah, it did it again, it capped it. So I'm gonna have to manually up it. That's pretty close. 26, 65, 60, 66, somewhere in there. So that's my max velocity. That's my stop velocity. So let's go transfer these numbers now. Now that I have the data that I needed from GRT that I used from my published data, my safe starting points, this is the numbers, these are the numbers I'm going to take with me to the range. So again, Varget, I'm expecting this velocity at 80 degrees, and this is the max velocity. N150, 42.5 grains, estimate around 2,500 feet per second, and maximum 2665 at 65,000 PSI. So now we have to go ahead and load up these rounds. I load up 5 rounds of each. If you want to try to save components, you can just do 3 rounds of each, and that'll get you closer in the ballpark, but I find that 5 rounds gives me just a little bit more fidelity when I'm doing these baseline workups. Okay, so here on the left side, I loaded the Varget, and I can trickle it to the kernel to get exactly 42 grains. On the right side, I got the N150, where I can trickle it exactly to 42.5 grains. And when I'm doing small workups like this, I just do it by hand. If I'm doing a full ladder or a lot of rounds, then that's my open trickler that I 3D print in the background. I'll throw that on top, and it's basically like an auto trickler. But you can just as quickly do it by hand for just these 10 rounds, just to start out. And then I also use a Sharpie, and I write on the case. It cleans up with just alcohol and a paper towel, comes off clean. But I always mark my brass in case it tips over, falls out, drop it, whatever. You know what's what before you go and shoot. So that's just a little tip. So step 4 is to go out and shoot the rounds for your baseline. And you need to have a chronograph. If you do not have a chronograph, GRT is pretty much going to be worthless to you. But also after you shoot the baseline rounds, you're going to measure your fired water capacity of those cases. So you can fine tune your profiles even further. I do cool my barrels 90 seconds to 2 minutes in between shots with my barrel cooler, just to keep the barrel from heating up and try to keep the velocities as accurate as I can. And I I went out and shot this today. I didn't use a target. I went to a BLM range, and it's free to shoot there. You can't go down range. They have steel plates out there, but I just set up a chronograph. It doesn't matter which 100 yard, 200 yard range, doesn't matter for this. You just go out, have a chronograph, and measure your velocities. If you have a target and you can shoot at it, it'd be great just to get a baseline to see how accurate these are. But it's absolutely not required. So today it was 77 degrees, pretty close to my 80 degrees for the Varget. My first shot, the cold bore, was the fastest, but they were all pretty good. Average of 2583 feet per second, which is about 50 feet per second faster than what Gordon's predicted. And same thing with the N150. I was about 50 feet per second off. The nice thing is the ESs on both of these were very similar as well as the SDs. This shot right here was, I mean, this is really tight. This is really tight. This one was high. I don't know why. It must be something with the brass. The water capacity, I always measure these two for the baseline just to see if I got a bad piece of brass. I mean, it's right in there. It's right in the ballpark. So I don't know what that is. That could just be part of the dispersion, the natural dispersion of these loads. So I'm gonna go with let's see here, 5622, 5630. I'll probably use 56.3 for my fired water capacity. So it's a little bit higher than what was predicted. So, and I was still faster. So now that we have this concrete data, we're going to go ahead and update the powder profiles and rifle profile and really get set up for the actual load ladder or however you want to fully test your rifle. So let's do that next. Okay, let's start with Varget. So I said 56.3 is going to be my fired case capacity. This doesn't change. It was 77 degrees and nothing else in here. Okay, so for the velocities, remember there's two different ways you can do it. You can add measurements, you can add the charge, and then you put in here 42, and then you add the 5 shots if you want. I'm not going to do that because I already have my average velocity, so I'm just going to go straight to the, well, before I do that, I'm going to save this. Go to the OBT tune, and I'm going to put in my measured muzzle velocity average of 2583. Muzzle velocity, there we go. I'm going to compute, and there I am. So now I'm going to save that as a new OBT. This is the new file. Go ahead and close that. I'm going to go ahead and save this. There we go, Remington 78. And now this is my baseline profile. This is my baseline that I'm going to use for building my ladders with Varget. So I'm going to go ahead and close this one. Slide this over, save. Okay, so this one's good to go. Now let's do N150. 56.3, 77 degrees. And let's go ahead and save. Measured velocity 2548. Yeah, it was off about the same. There's a new KMBA. Create a new file, and there it is. So I'm going to go ahead and close this, and I'm going to save this with the OBT -OBT. Now close this original one. These are now my two baseline files. Okay. So now my powder profile is tuned to this rifle, and I can actually update this now. I'm going to add to database because it changed the OBT file, changed the KNBA. So now I'm going to rename this. I'll call it RAM 78 ELD-M. Update the date. And you know what? I'm going to give it a calibration of 0.8 because I'm fairly confident in this calibration. There we go. So create new. I'm going to use this one. Okay, save. There, now I got my new powder profile designed for this setup. Save. Do the same thing here. Add a database. Update the date. Give it a 0.8 because I can. You can do whatever you want. And that's me. Save it. There it is. There's the N150. So now it's saved in my user database. Both of these are saved in my user database. They're tuned for this bullet, for this rifle. And now you can start working your ladders. The other thing I like to point out with these updated profiles with the powder, I now have burnout before muzzle passage on both of these. And these are fairly lower power. They're around 54,000, they're around 54,000 PSI. You can see the burnout is much better than what the original profiles were predicting. So that changed significantly, as well as the load ratio. So now Varget's 93.4 and N150 93.7. Varget and N150 have pretty close load ratios depending on, you know, how much you push them. So, but typically what I see with N150 is you have to load about one full grain more than Varget to get the same velocity. So just a couple of tips right there. But now you're fully set up to go ahead and do those workups. So we just finished tuning the powder profiles in GRT for step 5, and then you build your ladders or build another charge weight for whatever pressure or velocity that your objective is, okay? But now you for sure have a good powder profile for your rifle combo and bullet combo. And if you decide to use this profile in another 308, it should be closer than the default GRT profile for that powder, the default Varget, the default N150. But as you can see, with the published data that we used to just start out, it kept us in a safe region, and we were only about 50 feet per second off, which is about 2%, which is pretty good. Okay. And now it's going to be even tighter, you'll see. So in the next video, I'm going to actually put together a ladder and maybe a target zone for a pressure to shoot at with one of the powders and go out and shoot at the range and show you the target, show you the resulted feet per second, see how close it was to the tune profile. And yeah, we'll take a look at it, analyze it, and you can see how it all comes together. So I hope you enjoyed this video. I hope this helps you get started on the right foot with a basic load with GRT and helps you with all the frustrations that you may have been having just trying to load something with GRT with the default tune and it not working out, because you have to actually tune that powder profile in your bullet in your rifle. Otherwise it's garbage in, garbage out. So shoot straight, and I'll see you next time.